Hello friends, welcome back once again. Here again I'm going to discuss another indefinite integration problem using substitution method. Alright, and here I have the question. I stand for integration, indefinite integration of sin x times sin x cos x, and I have told you the 6 steps to solve this. And the first step is take a look on the independent variable or the expression related with the independent variable, because that will help us in the second step. Right, so here the first step, I'm just looking at the independent variables containing expression that is cos x and x. And now my second step is to suppose a new function t in a such a way that the derivative of that should be presenting should present already in this question. All right, that should present already here, and by supposing that new function, we should be able to convert the whole integrand into the new term of t. All right, so here two options are here. Either we can suppose x, whose derivative should be presenting here, or we can suppose cos x. All right, we have two options. If I'm supposing x, then the derivative will be 1, because derivative of x with respect to x is 1 itself, and 1 is though here present, but it's very difficult to convert all the integrand into the perfect form. It's easy, it's not that much difficult. You can do it, but that's not the thing, that solving a question with difficult method, difficult way, that's not our motto. We are using substitution method to make integration easier, right, not a complex. So here the question becomes easier when we suppose t equals to cos x, because the derivative of cosine of x, that is sin x, is already present here. Negative sin x it is, but we can put the negative, that's not a big issue. So that's why I'm supposing t. That's my second step. And my third step is differentiating this with respect to x, so that I can replace this delta x. Alright, so dt over dx is now derivative of cosine of x, that's minus sin x. Alright, and the fourth step, getting relationship to get replace this dx properly. All right, so here I can say dt, all right, equals to sin x times dx. And what is this negative sign? Here was negative sign, but I'm keeping this negative sign for a while here. Okay, and now my fifth step is replacing all the variables, replacing all the integrand into the term of t. All right, so I equals to, now first I'm writing this sine cosine of x, sine, and in the place of cosine of x, what I'm gonna use, I'm gonna use t. It's sine t, and see, it is now it is sine x times dx, right? If you have rearranged it properly, then it is like sine of cosine of x times again this sine x. All right, this sine x times dx. So I already written here this one. And now in the place of sin x dx, I'm using minus dt. All right, so dt is here and minus is here. And now the simple process of integration. So integration of sin t is what? Is minus cosine of t plus some constant. All right, and now when this minus will multiply, it will be cosine of t and negative constant. Negative constant plus constant, overall you can write plus constant. All right, whether that the constant is negative or positive, that's simply an arbitrary constant. Now our final stage 6, and integral is cosine of t, and we need to replace now t with the main its original value. All right, we're going to just substitute the value of t as a cosine of x, so it's cosine of x plus constant, and that's our solution. This is how we need to do the substitution. All right, hope that this lesson will help you a little to solve the problems related to the integration by substitution method.